Geometry, Chapter 2, Section 1. We are looking at conditional statements. So let's take a look at the statement. All birds have feathers. Now I can take that statement and I can change it into an if-then statement to look something like this. If an animal is a bird, then it has feathers. Okay, so that makes it a conditional statement. It has to be the animal has to be a bird, and then that bird has feathers. So we have two different statements, or two different pieces of the statement here. We have a hypothesis and a conclusion. And so the hypothesis is the statement at the beginning. If an animal is a bird, that's the hypothesis. And then the conclusion is, then it has feathers. So what I want you to do at this time is I want you to create 5 of your own if-then statements and identify the hypothesis and the conclusion. And then when I check your notebook, I will go ahead and take a look at your 5. So go ahead and do that at this time. Pick 5 on your own. Okay, now that we're done with the 5, let's talk about the negation of a statement. So the negation is just changing what the statement says and making it opposite. So if I have a statement that says the ball is red, then my negation, I'm just going to label it with in, then my negation is the ball is not red. And this will become important when we start making some truth tables here in just a minute. So negation statements are just the opposite. Now, you could have one that already has a not in it. Maybe you have the statement, the dog is not, let's go with old. Okay, the dog is not old. So the negation of that statement is the dog is old. Okay, so we can negate a positive. We can also negate something that's negative and get it back. Okay, so the next ones, we want to talk about 4 different forms we can put this in. We can put this, or related conditionals is what I'm looking for. We have our standard form, if P, then Q. That's our hypothesis and conclusion. We can write the converse of that. We can write the inverse of that, and we can also write the contrapositive. And so I'm going to go over those right now. So let's start with a statement. And let's say, and this is just in general, if today is Friday, again, just making a general statement, then tomorrow is running out of room. Let's see if I can squeeze it in there. Saturday. So my hypothesis is going to be if today is Friday, and my conclusion is going to be then tomorrow is Saturday. This is written as a conditional statement, and it's read if P, then Q. So alphabetical order, P comes before Q. P in this case would be my hypothesis. Q would be my conclusion. Okay, so this is my P. This is my Q. Okay, so that's our conditional statement. So we're going to change that up and we're going to do the converse of it. Okay, the converse, if P then Q, all we do is switch the order. So converse is if Q, then P. So it would be read something to the effect of, if tomorrow is Saturday, then today is Friday. Then I'm going to write the inverse, and so I'm going to take my original statement and I'm just going to negate both of them. So if not P, then not Q, and that's what the not looks like, just a little squiggly line there. So if today is not Friday, then tomorrow is not Saturday. And then finally I'm going to do my contrapositive, and my contrapositive is just the opposite of my converse. Whoop. Okay, so it's the opposite of the converse, which is going to be if not Q, then not P. And let me scroll if I can get back to my words there. So we say if tomorrow is not Saturday, then today is not Friday. So again, that's the regular conditional statement. I could just kind of wrote that in the wrong order. Let me change that a bit. See if I can drag this over here. And that's my conditional. Okay, so my conditional statement. Okay, conditional, converse, inverse, and contrapositive. Okay, so now we're going to make what's called a truth table. And we're going to use our conditional statement, if P, then Q. Which means we need to know the values of P, and we need to know the values of Q. We want to get every possible combination using trues and false. So we're going to start off with true, true, false, false. This is just a given. This is how all of the tables will start. Your P will always be true, true, false, false. And then we alternate the Q. Notice that each one of those combinations is different, and we cover everything, both being true, both being false. First one true, second one false, first one false, second one true. So in my conditional statement, if my P is Q, if my P is true and my Q is true, then the entire statement is true. Going back to our statement a little bit earlier, if today is Friday, then tomorrow is Saturday. Well, if today is Friday and that's true, then tomorrow is Saturday, that's also true, then the entire statement is true. The next one, if my today is Friday is true, but my tomorrow is Saturday is false, then that makes the statement false. If my first statement is false and my second statement is true, then they are true. And the last one's a little bit interesting, but if both statements are always false, then the if-then statement is true. And we'll look a little bit more into that in class. So there are some things that I could that I could add to that. I could add, and unfortunately I didn't do a good job here. Let's see if I can add to this table. Give me a second. Okay, so I could add some things to this chart. I could add a not P and a not Q. So then I would go over to my P column and I would just negate everything. If it was true to start out with, now it will be false. Again, just looking at the comparison of this one to what I'm doing here, these will be totally opposites of each other. So the second one is true, which means over here, which means over here, the second one will need to be false. Last two are both false, so they would be true over here. Not Q, I'm going to take that column, and I'm just going to take the opposite values. So that's going to give me false, true, false, true. Okay, now I could do, let's go with not P, then not Q. Now be careful, I can't just totally negate my statement over here. I have to go with the rules again. And so if I have two falses, ooh, that doesn't look good. If I have two falses, then my statement is true. If my first is false and my second is true, then my statement is true. If my first is true, my second is false, my statement is false. And then if they're both true, then they have to be true. That's actually the inverse that I just did. Notice it's not P, then not Q. This is the inverse. And so that is Chapter 2, Section 1, Conditional Statements. A little bit lengthy, about 12 minutes long.